at scientific notation. So scientific notation is a notation used for very large and very small numbers. Okay, very large and very small positive numbers. So what it is here's the definition. It's some number, which I'm calling A right now, times 10 to some power. Okay, this is an integer. It can be negative or positive. And A is between 1 and 10. Alright, so let me show you some examples to try and clear that up. So the first example will be 4.3 times 10 to the 4th. Okay, that's the number in scientific notation. Fits the definition. This first number is between 1 and 10, and 10 to some integer 4. That's a big number. What we're going to do eventually, or here shortly, is go ahead and write this in standard notation, just what the number would be. But you have to understand that 10 to the 4th is a 1 with 4 zeros behind it, right? That means 10 times 10, 100 times 10, 1,000 times 10, 10,000. So it's really the same thing as 4.3 times 10,000. Okay, that's 10 to the 4th, 10,000. Which is the same thing as 43,000. Okay, so I'm going to show you how to do that. I'm going to explain how to do that, but right now this is just introduction, is that this number we like better than using this. Right? It's just easier, it's just shorter. It's like an abbreviated version of this guy. This one's not too big, but once you get into the millions, then just think about a whole bunch of zeros at the end of this. You don't want to write that every time if it's in some report or in a book or something. Okay, so it's a shortcut. So let's do one more example just to show you the negative, what that means. So if I gave you 3.2 times 10 to the negative, let's just say negative 2. So we got to think about that. What's 10 to the negative 2? Well, you know your rules of exponents. So that'd be 3.2 times 1 over 10 to the second, right? Because we just studied exponents, which is 3.2 times 1/100th. Okay, which is a really small number. So if you want to write that as a decimal equivalent, we haven't talked a lot about decimals, so let me show you. Maybe 3.2 times 0.01. That's 1/100th as a decimal. That's 1/100th as a fraction. So this scientific notation right here means the same thing as this. 3.2 times 10 to the 0.01, which I'll show you how to do this. You might be figuring it out already. Is the same as that number. Okay, 0.032. So don't like these numbers. We're going to use this scientific notation just as a standard way. Okay, you'll see that a lot with really big and really small numbers. Okay, so if it's, in other words, if it's a negative exponent, it's a small number. It's less than 1. Right? 3.2 times 10 to the negative 2 is a number less than 1. It's this number right here, less than 1. And if it's a positive exponent, it's going to be a pretty big number. That is, 4.3 times 10 to the 4th is greater than 10. Pretty big number. Okay? So what are we going to have to do? Well, we're going to have to write numbers in scientific notation. Okay, so we're going to figure out how to do that. So that's our first task here. Write in scientific notation. I'll abbreviate scientific notation. Okay, number 1. Write the following number in scientific notation. Let me try to do that 0 a little bit better. 98. One more try. 98. Okay, so it's 9,800,000. Alright? So we got to write in scientific notation. It has to be in this form, this A times 10 to the n. So my first number has to be between 1 and 10. Okay, so you look at your numbers, you got 9,800,000. Where are you going to put the decimal place? It's all about moving the decimal place. Right now this decimal place is right here. There is no decimal place, but you can put it in. because 9,800,000, there's a decimal place right there, right? So basically you would move this all the way so it's between the 9 and the 8. Why do I put it between the 9 and the 8? Because that first number has to be between 1 and 10. 9.8 is between 1 and 10, right? If I put the decimal place here after the 8, then 98, that's no good. That wouldn't be between 1 and 10. Okay, so it's 9.8 times 10, and then I have to figure out what the power is. How do I do that? I count how many spots I move from here to where the decimal place is. Okay, so I do that and I count. So it would be 1, 2, 3, 4, 5, 6. So 9.8 times 10 to the 6 is the same thing as 9,800,000, right? It's just a multiplication. If I multiply that by 10 to the 6, 10 to the 6 is actually a million. 9.8 times a million is 9,800,000. Okay, so that's the process. Find the decimal place, put it to the numbers between 1 and 10, and then count. That's all you got to do. Let's do one more of those. How about just 1,200? Okay, so in scientific notation, that's going to be, the decimal place should be between the 1 and the 2. Right, so in order to make that first number between 1 and 10, it'd be 1.2. And then times 10 to what power? So I'll do times 10 and then figure out the power. We have to go 1, 2, 3. 3 spots, and that's it. Okay. 2 more examples in this video. Example 3. So now we got to deal with the little guys, the little numbers. 0.0000331. Okay? Alright, so once again I have to put the first number has to be between 1 and 10. So here you're going to move the decimal place in a different direction, right? Where we're going to move it right here between the first 2 3s that we see as we go from left to right. So it's going to be, that's going to be equal to 3 point, and then I include the rest of the digits behind it, 331 times 10 to what power? Well, how many spots did I go? 1, 2, 3, 4, 5 spots. Okay, but it's got to be negative, right? Like I said at the beginning, if it's a small number, you got to recognize that as a small number. It's a very small number. It's a lot less than 1. So I got to make the connection like we did up here, negative exponent, small number, right? Same thing here, small number, negative exponent. Okay? One more of those. 0.0041 equals, so the decimal place would have to go between the 4 and the 1, and so that first number is between 1 and 10. And then it's going to be times 10 to some power. You would move 1, 2, 3 spots. So puts a 3 up there. Now you got to recognize small number, negative exponent. I don't like to memorize to the right and to the left because that can get confusing. I just say, look, that's a small number, so I know that the exponent must be negative. Make those connections. Okay? So do some practice with those. There's going to be one more video on scientific notation.